this is direct and inversely proportional, the extended version for higher tiers. You have to know the other stuff before, but then also this stuff. So when we say y is proportional to x, or y is inversely proportional to x, in mathematical terms we can write something different. So that's the English, and the way we read this is we do y, so we write y, that's the same in math, is proportional to, which you replace with this fish. So I used to say y fishy, and then x. Again, that's already in maths. So y is proportional to x means you write y fishy x. This means is proportional to in maths. So that's the translation. Y is inversely proportional to x. So let's write this down as we go. So y is inversely proportional. So that's the proportional, but inversely means you do 1 over and then to x. So if you read that out, the translation to maths is y is inversely 1 over proportional fishy to x. So that's our translations. Y fishy x, y is proportional to x, y is inversely proportional to x, y is 1 over fishy x. Okay. Now, what we can do with the fishy, because we don't actually really know what fishy is, apart from draw him in some nice little stretch of water. So fishy in maths can also, we can replace fishy with, so that's fishy, but you can put is equal to k. So some value that you'd want to find out, some kind of rate of proportion. So instead of writing fishy, we can write is equal to x. So let's now do that here. So y is proportional to x is y fishy x, or y, replace fishy, equals k x, in which we find k. So each example is going to have a different k because it's proportional at a different rate, basically. Or if we were thinking back to our diagram on a graph, this k is going to be the gradient and it's going to determine like how steep that line would be. And in this example we've got y fishy 1 over x, so fishy replaces with equals k, then you've got over x. Don't have to write the 1 then. Okay, so we have two ways of writing y is proportional to and y is inversely proportional to. So what if I just wrote, this is a bit of a different one, if I wrote this. Okay, so I've just written down y is inversely proportional to x cubed. So how would I write that in math symbols? So again, just reading it like a book and translating like we just did. So you've got y, which is the same in English and maths, is inversely proportional, so inversely is 1 over, proportional is a fishy, and x cubed is there. So the only thing you change is this x cubed. And we can rewrite that, we know, as y equals, so instead of fishy, we write equals k over x cubed. So y, inversely 1 over, proportional is the fishy, x cubed underneath. Okay, let's try some more questions. These are exam questions because I might as well just dive straight in there and just like the fishy. And I really like these questions. Okay, so they all kind of come in this type of format. So let's see. C is inversely proportional to D, C equals 3, D equals 8, find C when D equals 2. So first of all, we're just going to kind of translate this first sentence English to math. So C is inversely proportional to D. So C, inversely 1 over proportional fishy to D, D underneath. Now we know we can write fishy as equals K, so C equals K over D. We've been given these pieces of information, so then we sub in, it's kind of the only thing we can do now, what we know, because we're ultimately trying to find K, we're trying to find like the rate it's proportional to. So C equals 3 and D equals 8. So C equals 3 equals K over D equals 8. Let's solve for K. So K equals 3 times 8, because it's divided on this side, so if we bring it up it becomes multiply. So K equals 24. Cool, now let's sub that into here. So we've actually got C equals, and we don't have to write K anymore because K is always going to be 24 from up here over D. What's our question asking for? Find C when D equals 2. So sub in D equals 2, because now we know K, and we get C equals 24 divided by D, which is 2, so C is 12. So they all kind of come in this format. Okay, so this next question. G is directly proportional to the square root of h. G equals 18, h equals 16, find the value of h and g is 2. So first of all, let's focus on this line. G is directly proportional to the square root of h. So G is directly proportional, fishy, the square root of h. Cool. We know we can rewrite fishy as G equals k root h. Okay, so that's all we can do so far, and then we've been given these values here, so we're going to sub in G equals 18, H equals 16. So 18 equals K and then root 16. We know that root 16 is 4, so we know that K equals 18, and we take the 4 over, so it becomes divided by 18 divided by 4, which is 9 over 2, or 4.5, however you want to write that. So now we know we can rewrite this equation. We found the value of k, very handy. G equals, instead of k, 9 over 2 square root of h. We are not done because it is not asking us for that. It's asking us for the value of h when g is 2. So now we're going to sub in g is equal to 2. So we've got 2 equals 9 over 2 root h. Take the 2 up, so 2 times 2 is 4. So it's divided on this side, multiplied on that side, 9 root h. Time multiplied by 9 on this side, so we divide by 9 on this side, equals root h. So we don't want square root of h, we want h. So the inverse operation when we take it over this side, if square root is squared, so we do 4 over 9 squared equals h. From the power rules, when you do this, you square the top and the bottom, so you have 16 over 81 equals h. So let's do another one. Okay, so similar again, x is inversely proportional to y, etc. So let's deal with this first. So x is inversely 1 over proportional fishy to y. We can replace the fishy with equals k. There we go. Now we're going to sub in the values we know. So we know that when x equals 12, y equals 9. So let's put that in. So x is 12. Equals k is what we're trying to find out, over y, which is 9. So to get k, we do 12 multiplied by 9, which is 108. So k is 108. Therefore, we can now rewrite this as x equals, we now know everything we need to know, k is 108 over y. What's it actually asking us for though? Find x when y is 81. So now we substitute y equals 81 into this equation. X equals 108 divided by 81, which is 4 over 3. Boom. So as you can see, all of those questions were in exactly the same style, did exactly the same steps. We're going to do our final example, which is a little bit different. Okay, so slightly different. Table shows pairs of values of x and y, so there you go. Take the correct one. So either y is proportional to x, y is proportional to x squared, y is fishy x cubed. So, sensible place to start. Let's just say that y is proportional to x and see what happens. So we know we can rewrite fishy as equals k x. Now we've been given these data values, so we can sub them in. So let's just sub these ones in first. We can say x is 2, y equals 32, so we can find a value of k. So 32 equals k times, and then x is 2 from our table. So we know that k equals 32 divided by 2, because I've taken the 2 over and it's multiplied on this side, so it's divided on that side. So k is equal to 16. Therefore, we can rewrite this. Instead of putting a k, we can do y equals, instead of k, 16x. Now, because we've got another value, we can check this work. So if the value is proportional to, k should work for every single set of data. So let's check. So from these, let's substitute x equals 3, and we should get y is equal to 72. So whatever our value of k we worked out, it should work for all values. So let's see. So y equals 16 instead of x multiplied by 3. So what is 16 times 3? That is 48, which is not equal to, so that's equal not, to 72, so therefore this cannot be. So we're going to have to go and try the next one and see if that can be. So now let's try y fishy x squared. Y is proportional to x squared. Same steps, we know that we can rewrite fishy as equals k x squared. We have some data points, so let's substitute again x equals 2, y equals 32 and see what k would be. So y equals, so 32 equals k multiplied by x squared 2 squared. So 32 equals k multiplied by, and then this is 4, 2 squared is 4. So k is 32 divided by 4, because you brought the 4 round, so you've done the inverse operation, so k would be 8. Okay, so we can rewrite this then as y equals, not k, but 8x squared. Let's do another check. So if we put in x equals 3, we should get y equals 72, because this k value should work for all our values. Let's try it. So y equals, so we're substituting x equals 3, 8 times 3 squared. Y equals 8 multiplied by 3 squared is 9. And 8 times 9 is in fact 72. Bingo, so we know that that does work for both data points. So we know our equation would be this, because we found our k value, so it would be y equals 8x squared, and we know that y is proportional to x squared, y fishy x squared, so that is the one we tick.